Hello, I'm Grace and this is my week 1 presentation. These are the materials I used to complete this experiment, and the brand of gummy bears is Black Forest Gummy Bears. So for this experiment, I chose to use 3 orange gummy bears because I thought they would be the easiest to observe with their color not being too dark or too light compared to the other bears. First, I poured 1 cup of water into each container and labeled one water and the other salt water to avoid any confusion. I also want to apologize for the orientation of some of these videos as it won't let me rotate them. Next, I added salt to the salt water container with about half a tablespoon at a time and stirred the solution until a saturated saltwater solution was formed. I ended up adding a total of 3 tablespoons to the mixture. And in this video, it just shows me adding and stirring in each amount. So observing the water alone, you can see a clear difference in transparency between the pure water and the salt water, as the saltwater solution is cloudier. Finally, I added the gummy bears to the 2 solutions, 1 in each solution, and left it undisturbed for 6 hours. You can see in the video the gummy bear in the pure water solvent is easier to see compared to the saltwater bear that looks more like a blob or blur. This video is actually a time lapse I took for about 20 minutes, and if you look carefully at the water solvent gummy bear, you can actually see it already start to swell, which is pretty neat. Oh, sorry. It's kind of difficult to see, but if I kind of jump forward, you can see it jump up versus back there it jumps back down. So that's pretty neat. So 6 hours later, these are what the gummy bears look like, and both have lost a lot of their orange coloring and were a very slimy texture. I actually had a bit of trouble getting the pure water gummy bear out of its container as it was very slimy and delicate. Here are the results out of the water. As you can see, the pure water solution caused the gummy bears to swell in size compared to the controlled gummy bear, and the opposite results happened for the saltwater gummy bear as it shrunk in size a little bit compared to the controlled gummy bear. And as you can see, a normal gummy bear is about 2 centimeters tall from foot to the top of their ear, and in the plain water solvent, you can see that it grows in size to roughly about 2.5 centimeters. And the length of the saltwater gummy bear still remains pretty much 2 centimeters, but it definitely looks smaller in size compared to the normal bear. Again, I apologize for the orientation. I tried my best to avoid this when I was recording the video, but you can see a closer look at each bear. So, why does this happen? The swelling and shrinking of the 2 gummy bears is because of osmosis and reverse osmosis reactions. First, we will focus on the pure water solvent gummy bear. As the description of the assignment stated, gummy bears are made of sugar, starch, and gelatin. This composition creates a cube-like sponge structure, as you can see in this picture. Ignore that part, please. And this allows water to enter the gummy bear. The gummy bear and pure water was able to swell in size because of its semi-permeable membrane that the gelatin creates. What this means is the gummy bear structure can allow certain molecules or ions to pass through the membrane, and as the textbook states, these molecules or ions have to be a certain size, shape, polarity, charge, and so on to pass through. The transferring or diffusion of solvent molecules, aka the water in this case, is referred to as osmosis. And as you can see in the picture, this membrane would be the gummy bear gelatin structure that allows water to pass through into the bear. The state of this gummy bear is called hypotonic, which you will see in a diagram on the matter in a brief minute. And this is when osmotic pressure inside the gummy bear is higher than the water, which causes the water to enter the bear, leading to the swelling of the bear. This can lead to the expansion or even rupturing of the subject, which explains why I had trouble of getting it out of the water without damaging it. Which you can see right here, there's kind of a dark line area that's actually from me puncturing it because of its delicate state. Now, if we look at the saltwater gummy bear, of course, it's going to have the same characteristics, but as you can see, salt cannot enter the bear. Since salt cannot enter the bear and water follows salt, this leads to a hypertonic solution through the process of reverse osmosis. And instead of bringing ions together in the membrane, it actually separates them. Hypertonic has the opposite reaction as hypotonic, and causes the bear to shrink as there are more salt molecules in the water than in the bear. And if this was a cell in the body, this could lead to crenation, which is where the cell would shrivel so much till it dies. As you can see, these cells are in a more shriveled state, and that's like what the bear is experiencing. Here's a diagram that shows the two types of reactions compared to the normal state, and you can see how it affects the size of the gummy bear, where hypotonic is the swelling and can lead to rupturing, and hypertonic, as I said before, is the shriveling or shrinking. Well, this concludes the end of my presentation. Thank you for listening.